Okay. Is it visible? Hello? Hello? Can you see this slide? Can you see this slide? Hello? Hello? Can you see this slide?
Yes, sir.
കിട്ടുന്നുണ്ടോ? Hello?
സർ കിട്ടുന്നുണ്ട്.
Okay. So the next portion we have to cover is the relation between. Yesterday we talked about the transform. Last class we talked about the transforms. So all transforms is relate to each other. So it can be connected to one transform is connected to another. So today you can go for the relations between S plane and Z plane. Or we know that S plane is used for continuous time signals, and Z domain is used for the discrete time signals. Okay, so even though they have, they can you can make a relations between S plane and Z plane. So basically, what is the Laplace transform equation? That is S plane Laplace transform equation. Suppose if is Laplace transform of an input signal x of t is defined as xs is equal to integral of 0 to t, 0 to infinity x of t e raised to minus st. So this is a basic equation of an this actually it is a basic equation. Actually, it is limits is starting from minus infinity to plus infinity. But if you are considering unilateral system, it is equal to 0 to infinity x of t e raised to minus st dt. Okay. So, and next. Okay. So, when you make an sampling, when you make the sampling so that x star t, you can equal to x n t into delta t n minus delta t minus nt. After sampling the x of t, you get x of nt. So after sampling x of t, you can represent it like this: x capital Nt delta multiplied with an impulse transform. So shifted sequence of the impulse sequence t minus nt, where n is from 0 to infinity. Okay, so Laplace transform of x star t we can take as x star s, then which is equal to summation of n from infinity to x n t delta n t, which is equal to summation of n from 0 to infinity x n t Laplace transform of lt minus nt. Laplace transform of lt minus nt. So that is equal to summation from n from 0 to infinity x n t e raised to you can replace as e raised to nts. So this is basically Laplace transform. If you're taking the Laplace transform of delta t n minus t, delta t n minus t, when we're having this shifting property, this is a Laplace transform shifting property. So it is multiplied with e raised to minus n capital Ts. So this actually is a shifting of this one. Actually, Laplace transform of delta t is 1. So this is shifting. If it is having shifting, so it is e raised to minus nts. Okay. So next, the transform is a transform of the x nt is given as is a transform of x star t, which is equal to is a transform of x nt. X star t you can replace as x nt after sampling. So which is equal to x of z, which is equal to n from 0 to infinity x and t is set raised to minus n. So comparing the equation of this two 112 and 113, we can have the relations between the S domain and Z domain. So one is in the S domain, taking the Laplace transform of the shifted sequence, and another one is the Z transform of the X star t. So here, if we are substituting, suppose the relations between S plane and Z plane can be described as, if you close monitoring these two equation, so sum of from n from 0 to infinity x and t z raised to minus n. Here it is e raised to minus nts. So what is the all are common except when you substituting z is equal to e raised to st, so both the equations are same. If you are substituting z is equal to e raised to minus st, again same, both are same equations. Okay. So, what is the z? Z is represented as a polar form. The polar form is r into e raised to j omega, where r is the rotation, the vector, and angle is omega. So the vector is rounding in the s circle, and s is equal to alpha plus sigma plus j capital omega. So capital omega stands for is a um, imaginary term and as well as the real term. So this is a complex term. So the complex term having real part and imaginary part. ഇവിടെയാണെങ്കിൽ is equal to z is equal to r into e raised to j omega with the polar form. Comparing the equation 15 and 16 with the z, comparing these two, substituting z is equal to r e raised to j omega and s is equal to sigma plus j omega, then z e raised to st can be replaced as e raised to what it is, s can be replaced as sigma plus j omega t. So this is equal to e raised to sigma t and e raised to j capital omega t. Okay. So when you're substituting z is equal to r e raised to j omega, so you can as e raised to minus t sigma t into e raised to j omega t. And when you take the modulus of z, which is equal to, so when you take the modulus of this, e raised to minus omega t. So because you have e raised to omega t, and small omega, which is equal to checking this, so small omega is equal to capital omega into t. So here small omega is the digital frequency and capital omega is uh, capital omega. So analog frequency is capital omega. So the relations between these two, the analog frequency and digital frequency, is small omega is equal to capital omega t, where sigma is equal to 0. So modulus of z is 1 for sigma less than 0, modulus of z is less than 0, and for sigma is greater than 0, for modulus of z is greater than 1. So, so this is the relations between the S domain. So what is the relation? So suppose we have replacing this one, we can take as z is equal to r is to g omega and r raised to j omega and which is equal to z into r into e raised to j omega. So you know in z domain we can represent it as a real term and imaginary term if we make a circle. But in case of S domain will be a so next page. Okay, this. So this is a Z transform. We have a real part and imaginary part. So we have some circle, unit circle, and it is represented by the angle. Angle. This is polar form. This radius is r, so that r is rotating in the anti-clockwise direction with an angle of omega, small omega. So small omega here is replaced as or small omega, which is equal to same as capital omega t. Okay, so first omega is 0, this position, and if omega is increasing, it is moving towards anti-clockwise direction, and if it is omega pi by t is reached here, and 2 pi by t is again the same direction. So each, it is a repetition or periodic, it will be each 2 pi period, it will be 2 pi by t period, it will be repeated. So, but in case of S domain, is the right hand side is a S domain representation. Here also we have an S domain is real part and imaginary part. Depending on the value of S, we can mark the what it is or different poles and zeros. Here, the if we are mapping from Z domain to S domain, so the the point the or poles and zeros inside the unit circle is mapped towards the what it is a region which is in between pi by t and minus pi by t. Suppose a point, this point is mapping to a point inside the unit circle. Suppose a pole or zeros is placing any of this pi by t to minus pi by t, which will be placed inside the unit circle. Okay. Another one is suppose a pole is locating in the this shade, that is within the pi by t to 3 pi by t region. That pole or zeros is mapping again because here if we are say that one rotation, after one rotation again it is reached in the same point. So when you mapping a point in this point in this area, again it is almost same as the earlier one. So that means this is a repetition. The poles and zeros are repetition when you mapping from one-to-one mapping from S plane to Z plane. So what? So because this is a folding in S plane, there is no problem because the poles and zeros is placing between the uh, actual value. But when you are mapping from S plane to Z plane, if it is a one-to-one mapping or a impulse invariant mapping, uh, it will be always lies in the place inside the unit cell. That's the problem of these relations between S, S and also transform of S domain to Z domain. But when you in the DSP, you can have an alternative of this mapping. So when you're using bilinear transformation, so this problem can be avoided. Okay? So this is the relations between the S plane and Z plane. When you just to substitute what is the relations, this relation is if you are substituting z is equal to e raised to st, the you can have the you can convert to z domain to s domain. Okay, so this is a theory behind the conversion of relation between z domain to s domain, or vice versa. Vice versa, you can convert from here to here also. Okay, so we can go through the problem so that you can easily understand how to convert from Z domain to S domain or S domain to Z domain. So next problem we have, we can go for this is the last module portion, sixth module. So consider, okay, consider a system HZ equal to 0.2 Z by Z plus Z plus zero point 0.4 into Z minus 0.2. Its ROC is Z is equal to greater than 0.4. Okay, so, so you feel that this is an we get some system function which is of something. So what are the findings? First, to find impulse response of the system. First, to find the impulse response of the system. Next, B part, is DTFT exist for the system? If so, how? If DTFT is exist for the system, if so, how? And find DTFT. Okay, so here we have the HZ. From the HZ, we can find impulse response, and from the impulse response, we have to calculate DTFT. Okay. So first portion, A part is okay. It's a direct question. You can take a simple. Is it okay? You can take a just a simple inverse Z transform. So we have an H Z 0.2 Z by Z plus 0.4 into Z minus 0.2. You can take this problem, this type of problem we uh, found earlier. 0.2 Z by Z by 0.4. So for conveniently, HZ by Z, so the Z is taken in the denominator, so that right hand side only 0.2 by Z plus 0.4 and Z minus 0.2. So why we take as because uh, in your standard conversion from Z domain to inverse Z domain, or a Z transform of a basic standard signals, it's all having Z by something. So that is why we take a Z, a reserve of Z, so that after taking the inverse transform, we multiply that Z. So, similar, all other steps are similar to the partial fractions. So first A by first fraction and B by second fraction, and you find A and B by substituting Z is equal to minus 4.4 and Z is equal to 0.2, so that these terms are cancelled, and you can find you can obtain the values of A and B. A is equal to minus 3 and B is equal to plus 3, plus 1 by 3. A is equal to minus 1 by 3 and B is equal to minus plus 1 by 3. Okay, just to so that A and B we can substitute here. So we care that our HZ is HZ by Z is the answer. So next, Okay. Next. Next. So after obtaining this one, again, so next is the HZ. We have earlier it is HZ by Z. That Z is multiplied into the right hand side. So that the whole term, earlier it is minus 1 by 3 by Z plus 0.4. Now it is Z by Z plus 0.4. So here also Z by Z minus 0.2. So now it is a standard equation of uh, a raised to n. So this is equal to minus 1 by 3. So a is z. This is in the standard form z by z plus a, or you can say that 1 by 1 minus uh, zero point 0.4 into or a into z raised to minus 1. Either or. So that minus 1 by 3 into a is minus 0.4 raised to n into u of n. Z by uh, z minus a is the actual standard form for an exponential sequence. That is why it is having a minus. So 1 by 3 into, here it is, okay, 0.2 raised to n into u of n. So this is an impulse response of the uh, standard inverse Z transform. And what are the poles? What are the poles? Poles of this system. Poles of the system of HSL. We can have first pole is Z is equal to pole. What are the poles? Poles of the system is nothing but the roots of the denominator. So here uh, the factors is z is equal to minus 4 and z is equal to 0.2, and there is no zeros. So that is why here is marked the poles of the system z1 is equal to minus 0.4 and z2 is equal to 0.2. And what is the criteria for stability? So stability say that in Z transform, if both the poles is lies inside the unit circle, then the system is stable. Then only DTFT is exist. So if both the poles or all the poles are lies in the unit circle, then only the system is stable. Then only the DTFTs exist of the system. So what are the poles here? Here one is pole is Z is equal to minus 0.4, and another pole is Z is equal to 0.2. So both poles are lies inside the so last portion is to find the DTFT of the system. So DTFT H raised to j omega DTFT, which is equal to HZ when Z is substitute to e raised to j omega. So this is the relations between the DTFT and Z transform. So H raised to j omega, which is equal to HZ, where Z is substitute to e raised to j omega. So we can take the basic equation of HZ, then you substitute Z is equal to e raised to j omega. So that will be equal to the H raised to j omega. So it is simple. So it is converted from Z domain uh, to an DTFT form. So just to substitute z is equal to e raised to j omega, 0.2 into e raised to j omega by e raised to j omega plus 0.4 e raised to j omega minus 0.2. I think this is enough for ETFT, or better to in if you are um, if you want to find the magnitude response, the denominator terms we can should be vanished, so that then only we can find the magnitude and phase response. So now there is no problem. They ask for just to find DTFT, so that that expression is enough. Yes. Oh, that expression is, this is the final answer. This is the final answer. So here in this problem, we found that uh, the given is HZ. From the HZ, we have to find impulse response and check whether the poles is lies on the unit circle, whether all the poles is lies on the unit circle, then only the system is exist, or system is stable. Exist means it is the system is stable. So that system can be, we can take the uh, DTFT from Z domain by substituting Z is equal to e raised to j omega. Okay. Can we move to the next problem? Next problem. Anybody? Is it okay? Hmm. Anybody? Is it okay? Are you comfort? So next round. For a causal system, for a causal system, for a causal system is represented by a causal system is represented by the following difference equation. So yesterday in remedial class, we say that what is the causal system, and can be represented whether it is the discrete time system. So it is represented in terms of difference equation. So that is why y of n plus 1 by 4 yn minus 1, which is equal to x of n into half into xn minus 1. So find the system function and give the corresponding region of convergence. Okay, just to find HZ and find the ROC. So first you find HZ, then you have to, second question is find the unit sample response of the system. Unit sample response of the system. And last one is find the frequency response, that is h raised to j omega, and determine the magnitude and phase. So this problem having the magnitude and phase. Earlier we can find only up to this, but here it is obtain magnitude and phase response. So all we study, all the levels, all different portions we study. This is a mixture of uh, Z transform. First, if system function we have to find. Second is it is an inverse Z transform. Then you conversion from Z to DTFT. After that, it will be to find the frequency response. So determine magnitudinal phase response is nothing but the frequency response of the system. Okay, so this is a complete problem having all the flavors. So first you write the equation. So what is the next step? What is next for finding Z? We take the Z transform of this system, this difference causal system, because it is causal means it consists of only present time and past time only. So this is a causal, pure a causal system. We take the Z transform of the system. Applying the Z transform of the system in both sides. Okay, so that yz plus 1 by 4 z inverse into yz is equal to xz plus half into z raised to minus 1 xz. So how you just x y of n is conversion for yz. If it is an delayed element, to multiply z raised to minus n. Here n is equal to 1, so it is z raised to minus 1 yz, which is equal to xz into right hand side. Similarly, it is a delayed function, delayed signal. Okay. So system function is yz by xz. So we uh, group together yz and xz so that we can obtain hz, which is equal to yz by xz. But it is so conveniently you can multiply so that z plus half by z plus 1 by 4 is a system function for hz. And next to find what is the region of convergence. So even though this system is causal, okay, the system of causal, the region of convergence is z is greater than 1 by 4. Z is greater than 1 by 4. So is the system is stable? Is the system is stable? The region of convergence is 1 by Z is greater than 1 by 4. So for a system is stable, its unit circle is lies on the ROC. So that means Z modulus of Z greater than 1 by 4 means 0.5. So 0.5 is the ROC is greater than 0.5 means the unit circle must be lies in the ROC. So the system is a stable system, a causal system, or the system is exist. Next we find what is the unit samples, units response, which is the sample response of this exam. That is equal to, you just to apply h set. So the x of n is equal to delta n and x z is equal to 1. So just to take the inverse of the inverse transform of the system. So inverse transform again split into z by, this is easy one, no need of what it is partial fraction. So it's z by z plus 1 by 4, then half into z plus 1 by 4. So numerator we can split into system. Okay. Sorry, we will continue here. The local issues. Okay. So we take the response HZ. HZ is there's no need of taking the partial fractions. So what it is? First term we have a convenient term Z by Z plus 1 by 4. And next is half into Z inverse. We make an Z inverse so that there is a term of Z. Z inverse half into Z inverse into Z by Z plus 4. Okay. So this time the previous same as the previous problem. So we can easily convert it to this is an exponential sequence expression. So from this, if you are taking the inverse transform, the minus of 1 by 4, minus of 1 by 4, the raised to n of u of n, basic form. Minus of 1 by 4 into n u of n plus, here it is half into, again this is minus 4 raised to one delayed function. Z inverse is there, so that 1 by 4 raised to n minus 1. N minus 1 u of n minus 1, because it is delayed, one delayed element. In Z domain it is raised to minus 1, but in case of time domain it is u of minus 1. Okay. So this is the answer. So the impulse response, actually it is not y of n, it's a mistake, the textbook mistake. It is h of n, because we taking hz, from the hz it is inverse is a transform. So h of n is equal to this function. So this is an answer for impulse response. So last problem is, so we say that it is a stable system because the poles z is equal to minus 1 by 4 is inside the unit circle. So the system is stable, and we can find the Fourier transform of h raised to j omega, which is equal to, just to substitute hz is substitute z is equal to e raised to j omega. So we can convert from or transfer from or map from Z domain to your frequency domain. So that Z plus half by Z plus 1 by 4, where you substitute Z is equal to e raised to j omega. Okay. So that the term of Fourier transform of frequency, our aim is to find the frequency response. So it's e raised to j omega, which is equal to e raised to, you just substitute z is equal to e raised to j omega. So e raised to j omega plus half by e raised to j omega plus 1 by 4. Okay. Here, conveniently, so e raised to j omega, we can split into cos term and sin term. Cos omega plus j sin omega plus half. Then denominator cos omega plus j sin omega, similarly plus 4. So that, so this is the previous one is our what it is. This is an our Fourier transform. So for finding the response, we taking magnitude response and phase response. So magnitude response, we take the modulus of h e raised to j omega. Phase response is we taking angle of h e raised to j omega. So next we can find the magnitude response. Find the magnitude response. So that magnitude response, modulus of this is you can take root of square of imaginary term plus square of real, real term. So square of real term plus square of imaginary term. And denominator similar to square of real term plus square of imaginary term. So here, what are the real term? Cos omega plus half and cos omega plus 1 by 4. The real term is cos omega plus 1 by 2, and this is cos omega plus 1 by 4. And imaginary term, numerator j omega plus this is j omega. So it is equal to uh, real term square plus imaginary square root of. That is why the real term square plus so what is real term square? Omega square plus 1 by 4 plus the omega there is some mistake here. So omega by 2 is there. Omega plus mistake is there. In this textbook there is a mistake. So we use cos square omega plus uh, omega plus 1 by 2 plus 1 by 4 plus sin square. So here additional term is 1 by 2 is also there. 1 by 2 is also there. And denominator is cos square plus cos omega plus half. So here also some mistake. So you can correct it. Correct it this one as you just to expand cos square plus 1 by 16 plus cos omega plus 1 by 4 plus sin square. Sin square. So that the sin square and cos square is 1. So here also. So I have some values of a coefficient plus omega and coefficient plus omega of root of. So you correct the they are taking the mistake here. They are not including this 1 by half, and denominator also that is mistake. It is equal to cos square plus 1 by 16 plus what? That is 2 into denominator half into 2 into 2 into AB. Okay, oh, it was okay. Cos correct. So this is okay. And here what it is? Okay, half. So this is right. Cos square plus 2AB plus this one, and this is also cos square plus 2AB means 1 by 2 is over. So this is correct, no problem. Correct. The angle of h raised to j omega tan inverse tan inverse. What is the expression? Tan inverse is taking the uh, tan inverse of real imaginary part by real part minus tan inverse of denominator part the imaginary by real part. So that is why tan inverse the tan inverse not here. This we can go for the earlier one. What is that? cos theta plus half is the, so j sine by 0.5 plus cos omega. You don't consider that from this one. This is a magnitude response. You can phase response is obtained from the previous expression of cos omega, sine omega. So this is sine omega, tan inverse of sine omega by cos omega plus half minus tan inverse sine omega by cos omega plus 4. So that is why they taking here the angle of this one. Actually, to actual magnitude response and phase plot, we have to plot for different values of omega. Okay, up to this I am stopping here. Any doubt? Any doubt regarding this question? Here we convert mapping from Z domain to okay, no sir. Z domain to, can you speak? Somebody is, can you speak someday? What is the briefing of our today's class? So we take LT relations between S domain and Z domain. Taking the Z domain, from the Z domain we find the H raised to j omega. Hello, any doubt?